Our second unit is about transformations. No, not that. I'm talking about geometric transformations, how figures move and change in the coordinate plane. The goal of this unit is for you to gain a spatial understanding of how figures move and the mathematics behind their movement. Before we talk about our first type of transformation, let's look at a few vocabulary terms.
We are ready to start Chapter 4 today, and specifically we're only going to be in 4.1 and dealing with translations. So here in the beginning is our little warm-up, just trying to remember ideas about transformations from maybe some middle school math that you did. It's been a while since then. So take a moment and see with these 4 examples here, if you can determine if the shaded figure is a translation, reflection, rotation, or dilation of the non-shaded figure. And we're ready to check together. The first example is a rotation. It was just turned, so if turn is a word you like more at the moment, you can. The second one is a reflection. Another way of thinking about that is that it flipped over. The third example is a dilation. In this case, it shrunk compared to the original. And our fourth example is a translation. Another way we can think about this is a slide. Just slid over a little bit. And this last example, translation, is going to be our focus for today's transformation. So we're going to be pretty vocab heavy here in the beginning, and then we'll move into examples. So in general, a transformation is a function that moves or changes a figure in some way to produce this new figure that's called an image. So if you're a highlighter person, you need to remember, let's make that a little bigger. The new figure will be called the image. The new figure will be called the image. Another name for the original figure, the figure that we start with, is the pre-image. These vocab words are important, so I'm going to highlight using a different color so they stand out. So the original figure that we started with is going to be called the pre-image. Okay, a pre-image, we transform that and we get an image as the result. So one way we can show someone with our pictures this is happening is with what's called prime notation. Prime notation. So for example, if our pre-image is this point P, then its image is point P prime. It looks like a little 1 in the exponent. So if we were looking at a picture example of this, if we had this point, our pre-image point P, we can move it somehow. It gets moved, and it becomes the point P prime. So that's the exact notation we would use in a picture. So one way that we move figures in translations is using a vector. A vector is a quantity that has both direction and magnitude. Another way to think about that is a vector has its own size, and it's represented in the coordinate plane by an arrow drawn from one point to another. So down here in this example, it's the green piece. On the screen, it's green. That's an example of a vector. So here in this exact diagram, we can say that the initial point, the starting point, the starting point of the vector is P. You can see that down here. And the terminal point where the vector ends, is Q. So the vector that's doing the moving, the vector is named PQ. Now, it's a little hard to see there in the paragraph form. So the vector is PQ. Our notation looks like the top half of a ray. So we put our line above it, and then we only draw the top part of the ray. That's a little messy. Let's try again. There we go. Vector PQ. The horizontal component, the left-right, the horizontal component of PQ is 5 in this example, and the vertical component is 3. The vertical, the up-down, is 3. The component form of the vector, the component form of a vector combines both the horizontal and vertical components. So the component form of PQ is the vector 5, 3. So I'm going to highlight. Here's my notation, and here is what that component form vector looks like. This is called component form. If you want to write it right underneath your highlighting, great idea. This is component form. This is incredibly important because we're going to learn a new form in just a little bit. So let's practice. We've got 2 examples here at the bottom of our page. We have 5a and 5b. So the first thing we're supposed to do is name the vector. So using our example up here of vector PQ, we know we name vectors from the initial point to the terminal point. So here we go. This is vector JK. Your notation should be above it. And so now we're ready to write our component form vector. So we've got the pointy arcs on the outside. They kind of look like greater than and less than symbols. Just a little more narrow. So the first piece is how far we moved from left to right. So 1, 2, 3 is my horizontal component. And my vertical is 1, 2, 3, 4. So the vector JK, written in component form, is 3, 4. So I'm going to give you a moment to try 5b. We'll hit pause if necessary and give you a chance to write the name of the vector and its component form. Time for us to check. The name for this vector is BK. Remember, it's always initial point followed by terminal point. And then our component form. For this one, we moved backwards. So 1, 2, 3, 4, 5. We went backwards, so that's -5. We went backwards, so -5, because we went to the left. And then we went up. How many? Our vertical component is 1, 2. So we went up 2, that's a +2. Now it's a great time to ask questions about naming vectors and writing those vectors in component form.
The first type of transformation we're going to talk about is called a translation. It's one of the more basic types of transformations because it simply means moving from side to side, up and down, or diagonally. So let's define it a little bit more and look at some examples.
And now we're going to talk specifically about translations. So a translation is going to move every point of the figure the same distance and in the same direction. So here to the right is an example. If you're looking at the screen, you can see one image is blue, one image is red. So our pre-image, our starting image, is the blue. Down here, the arrow in the middle is showing us it's moving to our image, the red. Okay, so our points P and Q form the segment PQ. They've moved along this vector. This vector has led us to our red image, the segment P prime, Q prime. So they tell us here that two of these things have to be two things have to be true. The distance and direction they move here, this black line has some notations on it. The tick marks tell us that they have to be equal measure. So they moved the same distance. And those two black lines with notation must be parallel, or we must have collinear segments. Okay, so this is just an example showing us our pre-image moves along a vector to give us our image. Okay, so let's practice a translation together. I think there's a lot of scary vocab words when really doing a translation, performing one is much easier.
All right, let's look at number 6 here to practice translating a figure. Number 6 says the vertices of triangle ABC are A03, B24, and C10. So those are the points of our original triangle. And we're going to translate it using the vector 5, 1. We'll graph both triangle ABC, our pre-image, and its image, okay, the translated figure. Let's first start by graphing that pre-image. A is at 0, 3. B is at 2, 4. And C is at 1, 0. Here is our pre-image, our triangle ABC. So you start with that pre-image so you know where we're beginning. Okay? And now we're going to translate that figure. We're going to move it. And they tell us to move it along this vector 5, 1. Right? The vector is telling you your direction. Okay? It's telling you the direction that the triangle is going to be translated in. So if we're going along the vector 5, 1, that means we are adding 5 to each of our x's because we're moving right. Because it's a positive 5, we're going to move right with our figure, and so we're going to add 5 to each of the x values in our coordinates. And 1 tells us that we're going to add 1 to each of the y values. Okay? Add 1 to each of the y values in our coordinates because we're going to move up. Okay? So this is telling us we're going to move right 5, and this is telling us we're going to move up 1. Okay? That's what we get from the vector here, 5, 1. All right, so let's look, what would our new points be? What are our image points going to be? So A started at 0, 3, and we're going to translate it to A prime. So we'll add 5 to each of the x's and add 1 to the y, so 5, 4. So A prime will be at 5, 4. That's the translated point. B is at 2, 4, and to translate that along the vector 5, 1, B prime is at 7, 5. And lastly, C is at 1, 0. I'm going to translate that to C prime. That would be 6, 1. So there are the points for our image, okay, our translated triangle. Okay? So let's put that onto the graph, because that will show us how the figure is moving. So A prime is at 5, 4. B prime is at 7, 5. And C prime is at 6, 1. So there's A prime, there's B prime, and there's C prime. And so you can see our figure here, all the points have moved over 5 and up 1. Okay? It's the exact same shape, it's in the exact same direction and orientation, okay? It just has moved over 5 and up 1.